And start recording on us locally here. But she's recording as well. Okay.
Hi, I'm just popping in to see how things are going.
Jessica has joined us. We'll see if anybody else does. If not, I'll go ahead and get started here in a couple of minutes.
Okay.
Recording this video, I'll go ahead and set up an introduction for it. So this is for the wind power event for both divisions B and C in the 2024 Science Olympiad competition. Wind power is an event that has returned after an absence of several years. Fairly simple and straightforward. You'll be able to find certain PowerPoint presentations all over the place. So I don't have a formal set of slides for that. I want to focus on what I think from my experience now going on about almost 20 years with Science Olympiad as to what coaches can do to help their teams perform the best. Wind power is one of these events where teams will build a device. It's a very simple device, very passive device to test at site. But then half of the event itself is due to the exam scores. And for that, again, there are resources out there, more numerous than what I could provide. There are various topics for which questions will come from. And often there it's more up to the individual students as to how much effort they'll put into studying those specific topics, finding sample questions to practice with and so forth. And it's up to the event supervisors at both the regional and state and higher level to try and gauge the difficulty level of those questions. So generally, I think the exams tend to take care of themselves in that regard, and coaches can just help students by providing as much resource material at the appropriate level for them to study with. And you could also, of course, prepare a binder of materials to bring with them. So effort in making that as efficient as possible is good to do as well. But that's all more the traditional academic setting of making study notes, making preparation. I think most coaches are pretty good at dealing with that task itself. Because wind power does have the three-wing binder, which can be numerous, but the exam does have a time limit. So students do want to be more efficient in preparation materials and knowledge of it, so they're not simply looking up answers all the time as they go through it. All right, so Heather has joined us as well, so that's good. So I've got the lights kind of down low here a bit, just because in this particular classroom setup, it works easiest if rather than trying to share a screen initially here, though I might do some of that later. As you can see, our projected display up behind me. Usually what I try to remind coaches is often there's so much focus on the initial description of what the event is about, what the test is covering and so forth, that they seldom ever get to the end result, which is where the actual important part comes from, is how will the teams be scored on the actual tournament day. And wind power is similar to other such events. I'll also do optics events later today. These that include an exam. The exam is generally about half the scoring. The other half of the scoring comes from a device testing in some way, or a performance of the team the day of the event. And so I just wanted to point out that you don't want to ignore those points that show up there. And in particular here, grab a pencil. Wind power, the exam's covering about 45 points. And then the testing, pretty much if your fan works good at a high-speed test, it's going to work good as a low-speed test as well. There's another 42 points there. We often see students lose out on 13 points of the total here because either they didn't do something as simple as bringing their device in a clearly labeled box with the team names. Teams have gotten a little bit smarter about that, but some of the things that the coaches can do is if you're not going to sit there and teach your students about wind energy sources necessarily, but you can make sure that they actually do fill out the appropriate chart with the graphs and data tables as asked. Doesn't have to be super neat or nice, just needs to be complete so they're not throwing away 10 points and just simply bringing the device in a box and gains them 3 points. So all the events that score this way, it's always amazing how many teams come and their chart is one sheet of paper. And so they're just throwing away points, which really does not require a great deal of effort, just a little bit of preparation leading up to the event itself to make these complete themselves in that regard. They'll complete those and do as well on the exam. And what I'm going to try to focus on today, which would be the unique part, since again, this event has not been offered in several years, is what you need to do to get a fan that's going to perform well on the actual speed test that shows up here. And the problem with that is if you look out at the resource material, it's way too dense for middle school. I know Jessica's in the high school, might even be way too dense for some high school students. We've got the resources out there pointing you to sites, but here's the problem, is that here's an example of a fan that was left over from years ago from actually Greenville High School. Not a very good design that shows up. But for the high school level, this one actually even failed initial dimensions. Zoom in on it a little bit closer here for you. You don't want to lose points either for not having appropriate construction parameters. There's a limit for high school, and if you start out again with just a simple CD, find these anywhere, and then they're going to attach their fan blades to it in some regard. For high school, the full diameter of the thing cannot exceed 28 centimeters. The radius is here about 14 centimeters, and that's actually quite small. For middle school teams, they can go out to a radius of 40 centimeters, which means 20 centimeters out from the center of the disc. That's still not huge, but much bigger in scope there. So you want to be sure you meet those minimum parameters. But beyond that, the issue is what you're trying to do with these fans, what the students are trying to do is make a fan that will spin the fastest. And the problem with all the resource material that's out there, well, it's not that it's not going to be helpful, is that airplane turboprops, so propellers for airplanes, they're not the same as a fan like you want here, like for a box fan. Box fans themselves, even energy generation fans, they want to be energy efficient in a way that either the fan can produce, or the blades can produce a large current to come out of the motor devices if you're generating current, or you want it to use as least energy as possible, let's say the case of a box fan, so it's very energy efficient in that regard. Well, it turns out that the design of this event, you want this fan to spin as fast as possible, so you really don't care about its efficiency in terms of the motor side. So that's why those websites will be useful to you. I want to point out back here on the board in a minute that there's really just a few things you want your teams to do, but then they do want to practice and experiment with this in order to make that happen. I'll go back to our full screen here. Like that for a moment. As when you look at your fan construction overall, first thing you want to do is make it lightweight, because for smaller things move faster. Also, you want to use lightweight materials that are out there. That's kind of obvious. As the rules specify, like no metals used in the fan, so you want to use thin plastics. You could use paper, thin cardboard, construction paper, balsa wood. The one here that's left over from years ago was made out of balsa wood, which I wouldn't necessarily recommend as a good material, but you also want a material that's molded. You want it to be lightweight, and then you want to experiment as well with the number of the fan blades. But that can vary. And that's something you want to experiment with again, because the whole goal again is to make this fan spin as fast as possible, not to make it energy efficient overall. And so you want to get lightweight, the number of blades can vary. Another thing is also to experiment with varying the pitch. And the pitch of the blade there just means what you want to do is, this is your disc right here that you have set up, is what you want to do is either have a fan that's almost parallel like that, or have one that's tilted up quite a bit like this. And that varies the pitch angle. Basically means how much air the blades will catch. And so the issue here again is all the materials out there is going to be talking about defining fan blades, but on the engineering side, they want them to be as efficient as possible. And what you want is simply a fan that will spin as fast as possible. And those two are kind of at odds with each other. And so you want to start with those initial designs. But the material that I've seen put out there by Science Olympiad, while it's a good starting point, it is way too dense. And when you find papers, say reference to these design things, it's going to be way too dense. So particularly for your middle schoolers, I wouldn't even go to those aspects. I would keep it something simple like this, get them to experiment with the types of materials they might use, lightweight materials that can be moldable in some sense, experiment with how many blades they will use. It's probably going to be likely that the more blades will be better here, but it depends a little bit too. You want to try to get like 10 blades, but versus like say 3, 4, or 5 blades might make a difference. And then varying the pitch angle here, have it something that they can experiment by tilting the blade up and down as it might go up there. And so they can have lots of fun with that. And how are you going to know when they're being successful with that? I showed the example here. This one, bring it back down in here for folks' review. This was left over again. This was actually a high school blade, which while it will turn and spin, it's very heavy. It's got 2 layers here of balsa wood to get something that's up. And that's really overkill in the sense, in addition to being too broad in dimensions. Here's one that I made for a moment that is simply just to test my apparatus device right here. I simply took 4 squares of cardboard, taped them crudely to this disc. I bent the cardboard squares, you can see they're up a little bit like this to give a little bit of a pitch angle to it, and that actually spins quite rapidly. So how elegant it might look, how aesthetically pleasing it might look, that does not depend upon the functionality. So they don't have to make it look pretty. What they want to do is just make it spin as fast as it can. And so really the way to check that is to have an actual testing station. You don't need a formal station that we would use, but they do need to take some time, hopefully not just take something like this together. How long did it take me to make this? It took me like 5 minutes to make this. And as crude as this is, it was performing about average of all the fans that the teams brought. And I put no thought into this again, other than just taping it, putting the cardboard up, and that was it that was set up there. So the kids can have fun doing this and trying different designs, but I would not stress to them to go out and look at design parameters or engineering parameters. All they need to do is make sure the length of these blades here is going to be within the dimensions. Again, from the center out to the edge, that's 20 centimeters. This one right here, across here, this one here from blade tip to blade tip. If I put this just kind of in the middle of both of them up there, meter stick over so you can see it better, but this is roughly here about trying to get this one to be closer to the high school dimensions, which would be 28 centimeters from blade tip to blade tip, crossing that right there. That's an easy parameter for you to keep track of, to keep in line. So, just experimentation and so forth, give them some freedom from that, let them try different designs. I wouldn't expect them to go too extreme, as in the cases of most of these build type events. Simplest is going to be better. Simple traditional type blade aspect of it work. And where they might start is even looking at existing commercial fan designs out there. Here's my box fan over here. It's set up. If you look at the blades inside the box fan there, I'll zoom in to that just a moment here for you. You can see that these box fan blades are kind of pointy tipped at the end. Why would you want a pointy tip at the end there? Because you want less drag that shows up out there. They're also always very thin. And so in addition to making something that's lightweight up here, you want them thin and as somewhat aerodynamic as possible as they're moving through the air. As I showed you here, even this very, very crude, very thick and crude cardboard here that's set up, even that turns quite effectively. So they may only see tiny, small improvements as things show up. Looking back at the scoring over here, back on for a minute. Is they need to score some points on those tests. That 21 points is based on scaling it to the team with the highest speed. Basically, we're just going to take the team span that performs the best, record wherever that voltage is, and then scale everyone else to score based on that. So you don't necessarily have to have the very highest speed that's going in, but you want to be competitive. You want a fan that does look like it's turning fairly fast. Anybody can jump in with questions at any point if they've got overall. Apparatus here set up just to display, because the other issue that happens often is
That's what I'm saying here.
it's not always a great expense, but to take the time with 23 events and set up a testing device that's simply for testing purposes, it's not something you're going to bring to the event, but so you can gauge the success of your students' devices that you're building there at school or at home. Can be a challenge. This one's fairly simple. I did look out on Ward Science. I think Ward Science is playing some game with Science Olympiad, and that they didn't show pictures or descriptions, but there was a listing on Ward Science for a wind power testing station, and they wanted $400 for that. I have no idea what they're making that's going to cost $400. It's very trivial setup that we have. Let me show you that setup like over here. So there's the box fan. I've got it on some little dab jacks just so I can raise it up. The reason the fan needs to be raised up, if you've got a 20 centimeter radius fan, that means its diameter can be 40 centimeters. So the middle school fans can be just about as wide as the box fan is itself. They need to be raising it up so they won't actually hit, down the floor. So we're moving on. And everybody has a box fan at home somewhere. And then the stand that I've got right here setting up, the key thing that you need in some way just to adjust that speed, go back in close here, is you need some type of, get closer on that because my camera will focus in over there. You need some type of small little DC motor. This is one I took, I think, out of an old phonograph disc or something of that nature. They're fairly inexpensive. You just bought one straight off someplace that shows up. What you might also find is interact workings of, say, the CD player, so forth. But sometimes the motors are a little bit bigger. But even if you don't have this motor, as long as you have a sort of almost frictionless bearing-like shaft somehow that you can put your fan on, because at the very least, you want the students to be able to put their fan in front of a box fan like this, turn on the power, and see how fast it spins. Even if it's just a qualitative assessment by eye that it looks like it's spinning faster now than it did the last time we had something set up. If you have a little motor device like this is really all you need. And you can find these around a lot of different places. The coaches themselves, your teachers aren't good at it. You got plenty of parents. Somebody must deal with old phonograph players or records or anything that turns like this. It's a little motor that works. And then you also need some type of little voltmeter. And these tend to run about $20 or so. But if you've got a physics classroom, almost certainly they'll have a voltmeter, something like this that you can use to measure it off of. They're not terribly expensive, but this will be a way to at least gauge more precisely and quantitatively what is the speed change that shows up because you're measuring the voltage that comes off here. Well, there's mention of putting a load resistor in a circuit. This is a very simple, trivial thing. Come back over here. I happen to have, because it was easy for me to grab here on short notice, pulling back my old supply of stuff. This is the big giant thing you're not going to have. This is just one of the rheostats we use in our labs here. You don't even really have to have that though for your testing purposes at home. The only reason this is listed in the diagrams, and that's for us really as testers, is it allows us to put the voltage in a more likely measurable range for us to deal with. But that's not even critical for your uses. You can take a simple motor device like this, and 2 leads coming out, and plug that straight into a voltmeter like this, and you'll measure a voltage coming off of the little motor as the fan turns it. I'll let you see what this fan does here. But at the very least, a box fan, a little motor like this that you can find somewhere, if you're not some old equipment you could salvage. You can buy these things for a few dollars, and a $20 voltmeter, and that's all you need to do a simple testing back at your schools. You don't have to do something really fantastic up there. So I'm going to run a test right here for you to show what we'll do. So I'm going to put my very crudely made fan blade here on. Now the stand we'll have, the one I've got here, is adjustable. I just got a ring stand. I can slide it up and down. I can tilt it back and forth. I can do all of that. The student teams are allowed to do all that during the competition. This is something else they can test, but I'll tell you this in the long run is they can also move this back and forth. If you go online and look for the videos, this is something that they'd want to try at home. Box fans are all kind of pretty much the same. If you get way up here too close, then the fan blades are actually out here on the edge. And right here in the very center, there's a big solid disc. So not much air is pushed right in the center. The air is pushed more on the edges here. So you normally don't want to be right up close, and you definitely don't want your fan blades hitting the box fan itself. But if you look online at the videos, and we won't tell the teams this during the competition. We will have this set up. We will have a fan. We will have a movable stand like this. So they'll be able to move it wherever they want, be able to tilt it however they want.
The kids, when they set it up, like they're not going to
Do
tell
that
them
for
where.
a few minutes. We won't have our meter running, but they'll be able to move that fan around, and we'll turn the fan on and off, and they can decide for themselves what's best. But I just want to tell you that these box fans are kind of standardized. If you've got one at home, they should do this before they come to the tournament and already know, we know where the best position is to place our fan. Okay? And in general, it's going to be probably, about maybe 6 to 12 inches out in front of the fan. They can try that again at their schools because there is no range of distances. This is one of the problems, right? Is that there is nothing that says the fan must be placed 12 inches to 24 inches away from the box fans. There's nothing that in the rules at all. We will have a fan set up. There will be a stand they can attach their fan to. They'll just pop it on just like I've done here. What I actually got on this right here is, this is a little disc off an actual old CD player that I just pulled out the little shaft to stick it on there. And then we will say, okay, you've got your disc mounted on there now. Position it where you want in front of the box fan. We can turn the fan on so they can visually see what's happening. We won't be recording anything, but they'll find that there's no magic here. Pretty much you want to be, probably about 6 to 12 inches right in front of the center of the fan. And you can try this for yourself, coaches at home. Just get a box fan. Almost everybody has one of these to use on one occasion or another. They're fairly inexpensive. And you can just stand in front of it and feel, where does it feel like the wind is strongest hitting your face? You want that point where the wind being generated by the box fan is most consistent and most strong. Of course, too far away, it's going to get weaker. Too close again, you're inside sort of the actual disc of the blades themselves. So I would strongly encourage so that the students aren't wasting time because they have, let's say, like about a 3-minute window in order to get their fan set up and then tell us we're going to test it. That should be more like 4 minutes, but in that 4 minutes, we have to run a 30-second measurement test of what their fan is doing. So I will turn the fan on here. You can see it turn. This is the highest speed for our setting here. Takes a minute to get up and start turning. There you can see it spinning quite readily there. And let me switch my view back here in a moment. So you look here. Oh, here. That out on that a little bit here. The meter fluctuating a little bit, so we would run like a 30-second test, take the maximum voltage that would be read off of this 30-second test. But while it's testing, the students aren't allowed to move or adjust things, so they have to do all this on their own. Now let's move it to a low speed setting here. Changing anything, you'll see that voltage reading has decreased down a little bit of a level there. The actual value of the reading itself isn't important. What's important is if your team's reading is the largest of all the teams competing that day, you're just trying to produce a maximum voltage. That voltage produced slowly by how fast that fan blade is spinning on the little motor there. Out and show you here that what happens, so we're at about 0.12 on that scale right there. Students might think, well, if you think of a fan blade, maybe if I hit it from the side, it's a little bit better. But again, they won't know while we're testing what these readings are. And they're not allowed to bring a meter with them, because they're not going to be hooking up to our system. They're going to have to know before they come again, what is the best orientation for their fan that makes it spin the fastest when it's sitting in front of a box fan like this. So I'm going to tilt it more towards facing towards you over there. It's still going to be spinning here. Switch back over to our meter view over here. We're down now to about 0.1, so I lost roughly about 20% of the speed because it's tilted a little angle. Two most important things, I think, for this event overall are test again these positions for a fan at home. And at the very least, even if you don't have something like that, with this other one here, in close. Off the box fan for a minute so that it's there. That if you have something as simple as this, I've got an old rubber stopper here. I've got that on the shaft of this little motor, not very nicely fit. Doesn't have to be on the motor. It could just be on a little, some kind of a little ball bearing apparatus. And you can find little ball bearings and all sorts of small wheels, even toy wheels for cars and so forth. There's some kind of shaft that I can put that on. And this just slips on the end of that rubber stopper really easy. So this isn't anything fancy. Just something that can spin easily here. And you could even just, because your fans will be so light, just hold that up in front of the box fan and watch how fast it spins. So even if, again, you don't have the setup to do some quantitative measurement with a meter or so forth, get them to practice, try their different designs, and even just by eye, they can watch it. And here's the other thing everyone can do, right, is everyone has a smartphone. So rather than trusting just your eye, they can record their little test on their fans here, and you can go back and look at those recordings. So rather than trying to do it on the fly, they can say, well, let's try this particular design. Or all these materials are cheap. Get them to have more disc. Here, so they could, the team members themselves, if they've got at least two, can be again part of this team, or even if it's just one person. The CD discs are cheap. Everybody has a bunch of old CD discs laying around by the different materials. just videotape even something as simple as watching them handheld on some little simple rotating shaft, how fast they can move. And then go back and even just qualitatively by eye, you could judge that this one looks like it's spinning the fastest of all of them and go with that design. And then figure out again, where is the best place for any generic box fan to have it positioned. When they come in to compete, they can slide it right to that position, maybe tweak things just a little bit to make sure it's lined as best as they remember it being back at home, and then they're good to go. All right, so I saw that someone's asked about the testing devices. That's our device here. Now you may see different stands around, but that again is the basics. Everyone will have. Go back to lighten that up again. Box fans may be mounted on different things. Online you can find. I don't know why they've got this crazy overblown wooden contraption. Set this box fan in. You can just set it on a wooden shelf or something, anything like that. We're not going to have a big fancy box contraption to mount it in. We will have two fans. We'll have one set up for high speed and one for low speed at our regional here. And then we'll have mount similar to this. We as a health department have all sorts of ring stands and mounts. We have all sorts of little variable like ring clamps and so forth that we can use. Online shows a PVC mount. You don't need anything like that at your schools. Leave that on the sites, the supervisors to figure out the best testing. All you need is the fan, and that fan is going to simply be snapped on to a standard CD test like little mount right in here. That's anything on any little CD player. In fact, what I'm going to do, not immediately, but beforehand, is I've got several dead old CD like boombox radios at home. They all have the nice little adapter holder in there. I'll just take some of those apart, pull that out to have on hand. But you don't need anything as fancy looking as this is with motors and wires connecting over to my meter and so forth. You can simply again do this just by eye and qualitatively, I think, gauge a fan speed fairly well. Now you won't see differences as small as like 5 or 10%. I think you can definitely tell when a fan looks like it's really going fast now versus one that's only kind of like average or so. Back to their designs again, back to that same focus that I started with. You want something that's lightweight material, that's flexible so that you can bend it. Make it as they did there, but bend it enough to shape those fan blades in some aspects like that. I think overkill is too much. Again, what I've noticed overall is that when you're talking about fan designs, you'll notice they want to be as much as possible air streamlined in some sense so the air easily flows past them, because the faster they spin, the more there's air resistance. So you don't want something thick again. You don't want that pitch angle to be too much. If you look again at my little blade right here, you can see the edge of the CDs. I barely got these little pieces of cardboard bent up. Now, they might work better if I bend them higher up. They might work a little bit better if I slightly slam them down, but fans do not have big extreme curvatures that shoot way up here. They're not big, fat, thick things that show up. You want it to catch as much air as possible, and then you want that air to be pushing on the blades to cause it to spin. And like I said, it's okay to start with all the designs I'll talk about out there, but part of the focus of this event is producing power by wind. And that's the opposite of what's going on here, because you've all seen the big giant wind tower blades. They do not spin fast. You don't want them to spin fast. The faster they spin, the more problems they run into in moving that mass of air. So you want them to spin slowly but efficiently with very little friction moving through the air, so that most of the energy goes into turning the actual coils of wires that are generating energy later on. So here the problem is, in this event, we do want this to spin fast. And so spin faster again, want this to have less mass, move through the air real smoothly, but to catch as much air as they can for that pitch angle that shows up there. Wouldn't let them do complicated designs. I think there may even be a place in here if they wanted to. They could try to go on and do some CAD program for high school. You could even, if you've got 3D printers they're playing with, 3D print an actual design of a fan blade that can then be attached, and that would be fine. And it's fun, I think, entertaining, educational for students, but we always like to point out is that while that's been included now because it's the technology in a lot of the Science Olympiad events where these devices are built, not just here, but in a detector building. You can even design something like that for the tower event and these other things is there's no bonus in terms of scoring for doing that. So if you have kids that love to do that, that's fine, but that's just considered part of your overall chart score or your log score of how you designed and did things, because they'll know not all teams are going to have access to 3D printers and the CAD drawing programs and so forth. So if it helps the team design something, but something as simple as a fan blade, doesn't really need that great extreme of design parameters. All it really needs is something of the right length, something of a generally right width, shape it a little bit so it's aerodynamic, and then adjust the pitch, which means tilt it in some way. If you're able to make that a more gradual tilt, that's why if it's a material that's a little more moldable and flexible, then that's fine. But really, these fans are going to be quite simple in their appearance and operation. But they do want to at least practice with a few different designs. They said what may be a recommend here, if nothing else, is what was kind of nice about this fan, although it didn't really perform that well, is that since these are so small and so lightweight to begin with, having more blades may be an option. There's not much room because, again, this is my very clunky, fat bladed things here, but I could potentially have put maybe a 5th blade on here. Because they're so close to the fan, we're trying to make it spin fast. The more surface area you have on these blades, the more wind it will catch coming from the box fan. That may actually make it spin faster, but it also is going to increase the drag in the air because there's more surface area to catch the air. So there's pluses and minuses to that, and there's no hard and fast rule. That's where they just need to experiment and try what works best on their designs. We'll start with a single sort of design for a fan blade that they like. Maybe add more around there. You know, just 2 blades isn't going to be enough. If they had a really big fat blade that's stretched out like this, they might have space to put like 3 of those on there. But a fat blade may not be as stable if it's very thin, flexible material. So there's ranges of options they can try, and that's where you do want to give the kids their freedom. High school kids can just kind of run with it. The middle school kids probably going to need more help and direction to think about things. They don't just go crazy and start sticking all kinds of stuff on top of their little CDs to make it work. But at least it's one that they're going to be using inexpensive materials. I would not recommend, I don't know why this team, unless they just had extra left over from some other device, would not recommend using balsa wood for the fan blades. It could use, but the one thing is the balsa wood is not shapeable. It's not malleable, so it's very stiff and rigid. So I would instead use something like construction paper that you can stiffen up, very thin sheets of cardboard, or plastics are very good. And then if you needed to mold the plastic, you can figure ways like to shape the plastic more in a cone-like shape, and then attaching it to your disc player here itself. I'll just use, again, crude Scotch tape here. You can use glues. There's all sorts of ways that you can attach to the disc. Can't use any metal anywhere. But you also want to make that structure rigid enough that it's spinning fast. You don't want it flying apart. Flying apart is considered like a safety violation, and that's no good. Do make sure that it's a robust construction that they have it there. So all the base of all fans must be a CD itself. All right. So this is the starting point. So, and they're only allowed to test 1 fan. They might. If you're working out with a fan, when they come in, there's not, in this case, there's no multiple things like in the flight program, they can bring 2 different planes, things of that nature. They're just going to bring 1 fan to test. So that 1 fan has to be attached to this CC. It doesn't have to be attached to the edge or to over here. You could even have a fan blade that might be pieces. There could be a piece coming right off here, and then you attach another part here. For instance, this is just my round one here. I'll just take off cardboard. It would be a better way to do it. So I could take this right here. I say, well, I want to attach, this would be over limit for some side, but say I want to attach this on here. I could take this piece and this piece, this is attached here. That's perfectly legal. Pieces like that would show up. But I think again, if you overcomplicate the design, you're going to defeat the purpose, because typically a simple single blade of appropriate dimensions, appropriate thinness and shape so it's aerodynamic, and then with the appropriate pitch is going to be most efficient and most successful at interacting with the wind blowing against it to start that force deterrent there. But there must be a CD because this has to mount on there, and you're not going to find anything better than that to begin with. So the base plate of all fans is supposed to be a standard CD disc. Other questions? Yeah, questions about the topics on the testing itself. Again, it's wide ranging and you never know what to expect. I've made up so many of these tests for so many different events overall. And so supervisors are instructed to take so many questions from each subset of devices out there, but there's no limitations. You know, it will say like question on, you know, how a power plant generates electricity. That's wide open. Could be the things that could show up. Basic physics principles behind that, wind power. So there, just find the appropriate resources yourself at the level of your students, what they can read and comprehend. And I would spend time for them to develop their three-wing binder, but as we all know, it's a testing environment and they are under stress for performing with their fans to begin with. So they're distracted by this apparatus that they've probably never seen before, putting their fan on there and excited about how it's going to perform. And oh, by the way, you got to go answer these questions over here on the side. So while the binder can be helpful, I'll point out that I never allow my students like open book exams because they've gotten the mode where they spend more time shuffling papers and answering questions. So if a binder is too dense with too much material, and they're just thinking, we've got all this material, we'll wait and look at that material as we take an exam. Again, this is true for all these events. There's just not enough time. There are too many questions being asked with a limited amount of time. You need to have that content knowledge already in place. Certainly, you know, maybe a list of vocabulary terms, something like that, that's brief to take a look at because the question maybe includes a word. They said, I don't know what that word means. They've got a vocabulary that's been alphabetized. They can quickly look up that word and say, oh, this is what the question's about. And it may help them answer it. But they're really just not going to have time to hunt through much material at all to help out with that. But again, that's something you should already be familiar with your own modes of testing whatever subject matter it is in whatever regard. Because the amount of topics that are covered are just too extensive and too extreme. Most supervisors, certainly here at our regional level, we try to hit the most basic topics and make the questions aligned to what would be a key phrase or concept that would stand out at certain testing material. But if they've got a three-wing binder that's got 20 pages of stuff in there, unless they have it very indexed so they can go right to the site that talks about that particular topic, that takes a lot of time to prepare that well. You usually find those binders aren't always as useful a reference for the exams. Label diagrams could be good because in the test questions, there may be figures or drawings that relate to things. So when you look at that list of topics, it might be better in that regard to help them out. Questions are almost of a multiple choice type. Rather than having dense reading material, to have charts or graphs or figures that relate to those topics, I think is always very useful to have, or even figures. You know, if nothing else, if there's something like a schematic of, say, a wind turbine that's generating electricity, to have a nice graphic that's a schematic that has labeled on there the different parts that show up. And you may not find this out there, but something that the students took time to create, you can not only label the part, but provide a brief little statement that this is what the part does. This is how that part functions. If all that's on one nice, say, one-page figure that's all labeled out there, then they can quickly go to that and find that information. And, resources like that are quite useful. All right, we got just a few more minutes here, but I think we got the Discord site going now. To work between coaches. Running out like 3 or 4 different Discord sites, but throughout your preparations leading up to the regional tournaments, we'll be making an effort to try to check in on that, see if there are questions that might pop up. I'll probably end up, I'm actually the regional site director here at ETSU. I don't end up supervising individual events so much, but on the physics side, we consider wind power. I'll talk about optics later on, all the sort of the build events. I'm usually overseeing how those testing apparatuses are set up and constructed and so forth. As I said, over 20 years, I've touched on all the events. So I'm happy if you want to direct questions directly at me, as well as just generally Discord, to try to come in and help out there as well. If there aren't any more questions, thanks so much for joining us and participating today. We have here Ray Machini from our chemistry department is going to talk about crime busters here in the next hour. Thomas Gold, who has assisted with our local middle school team, is going to talk about projectile motion in another room. Step forward to make sure he'll be ready to go here in the next 10 minutes or so. And I'll be seeing some of you in sessions later on this afternoon. Leave the session open here for a moment, but I'm going to go ahead and stop our recording.